pseudocode, but in a language called Scratch, a language called C, a language called Python, and more, there are certain constructs in programming, procedural programming, so to speak, that are going to be common among all of these languages. Highlighted in yellow here are what henceforth today and onward we're just going to call functions. These are verbs or actions that just tell the computer, or in this case the human, what to do. So those are functions. Now highlighted in yellow instead are what we're going to call conditions. These are branches, sort of forks in the road. So you can either do this, or you can do that, or maybe this other thing as well. But to make those decisions, you have to ask yourself a question. And those questions in computer science are called Boolean expressions, after a mathematician named Boole. And a Boolean expression, highlighted now in yellow, are just questions that have yes or no answers, or if you will, true or false answers, or heck, now that we know binary, 1 or 0 answers. So even in code, we see a hint of why 1s and 0s are helpful. Lastly, there's this thing here. Go back to line 3. We've used it in 2 places. That refers to something we'll call a loop. It's a cycle that does something again and again. So beyond those 4 ideas, functions, conditions, Boolean expressions, and loops, we're about to see a bunch of others as well. Variables, reminiscent of what you might recall from algebra, but more powerful now in this context of programming, something called threads and events. And we're going to do this by way of an actual programming language. But it's not yet going to be this one. Indeed, just a week from now, will you actually understand what this means? Odds are 2/3 of you have no idea what this actually is, and that's OK. But it's a program written in a language called C, more on that next time, that quite simply says hello to the world. But we're going to do it today in the context of a graphical language from MIT's Media Lab called Scratch. This is a language via which you can program a computer by dragging and dropping blocks, or things that look like puzzle pieces, that interlock together so that you can tell the computer exactly what to do step by step. And we'll see in this language today, and for the first problem set or programming assignment, that you can express all of these ideas from pseudocode in an actual language like Scratch. So what lies ahead? Well, at scratch.mit.edu, which I'm about to pull up myself, is going to be where you spend time in the first problem set. And it's going to look quite like this when you open it up. On the left-hand side of this website, this web-based programming environment from MIT, you're going to see on the left-hand side a whole bunch of puzzle pieces, so to speak. And they're categorized according to some different colors there on the left. In the middle, there's just going to be a big white canvas initially onto which you can drag and drop those puzzle pieces and lock them together to make the program do something. What can you make it do? Well, on the top right here is the so-called stage in Scratch. By default, there's only one character or sprite on that stage, Scratch himself, and he can move up, down, left, right, and do any number of other things if you tell him what to do by dragging and dropping those puzzle pieces. If you don't like that cat or you want many others, you can also add multiple sprites or characters by creating them in that area. So let's actually do this now with some sample programs such that we can actually begin programming using this environment. I'm going to go ahead now and open up a browser here. And in just a moment, you'll see on the screen scratch.mit.edu itself. So if I go ahead and create by simply clicking up there, we'll see this editor ultimately that by default has this tutorial that I'm going to go ahead and dismiss. But now we see that same environment. And you'll see that above Scratch here over at top right, there's this green flag and this stop sign. The green flag is what you can click as the human to make the program go. The stop sign will make any program stop. So it turns out, among all of these categories here, there's, for instance, some orange ones called control. There's some yellow ones called events. And we'll focus on this latter one first. If I go ahead and drag from events this puzzle piece here, this is how I can begin programming. When the green flag is clicked, do the following. What do I want to do? Well, let's have this cat just say hello. And from having used this program before, I know that under looks, I can go ahead and say something like say hello. And notice, not only does the shape match the orange puzzle piece or yellow puzzle piece, notice that it magnetically wants to snap together. And if I let go, it will. And I'm going to say perhaps one of the most canonical things to say in your very first program, which is just conventionally hello world, and leave it at that. I'm going to now go ahead and click the green flag. And voila, our very first program. The same effect. Thank you. Thank you. Very low bar so far, but we'll improve upon this next because this cat is pretty inanimate and is just now saying hello. What if we wanted him to do more than that and say not hello, but hello to me or hello to you? Well, it turns out we can do this a little differently as well. I'm going to go ahead and throw this away, by just dragging it over on the left, and the puzzle piece just goes away. And if I poke around a little further under these blue blocks, for instance, sensing, there's a bunch of puzzle pieces related to Scratch's environment. And one of those is this one here. Ask, what's your name, and wait. But that what's your name expression is in a white box that I can actually change. So you can ask any questions you want. But I'll go ahead and use that default. And now notice also over here in blue is answer, which is another circular shape which represents what we're going to start calling a variable. That variable is going to store whatever the human types in when asked for his or her name. So what do I want to do when I actually get the person's name? Well, let me go back to looks. Let me go ahead and say hello. And I'll go ahead and say hello, and then another one, say hello again. But instead of this, I want it to say my name, but it would be incorrect to just type my name, because then my name is always going to be David no matter who plays this game or is asked the question. So I don't want to do that. If I go instead to sensing and then drag and drop this puzzle piece, notice this. It wants to magnetically snap in there, and it will grow to fit it. So now I can say hello, and then I can say name. So let me go ahead and hit stop and play again. What's your name? I'll go ahead and type in David, enter, and now David. I feel like we forgot the hello. This is my first bug. Any thoughts as to why? What did I do wrong? Yeah. Yeah, I mean, I told the computer via this algorithm to do three things. Ask what's your name and wait. But then I just say, said hello, say answer, in such rapid succession. And my God, our Macs and PCs and phones these days are so fast. They're going to do so many things so quickly that it did say hello. It's just none of us really saw it because my name immediately overrode it. So I can fix this in a couple of ways. Let me go ahead and go back to looks for just a moment, get rid of this puzzle piece, and maybe say hello for 2 seconds. Then let me go ahead and say my name or the user's name for 2 seconds as by dragging answer now into here. So that was my first bug in code, so to speak. Let me go ahead and play again. Type in David, and now it's hello, David. All right, so better. It's a little weird because you typically don't greet someone by saying hello, David, 2 seconds later. So what if we kind of combine this expressions and say not hello world, but hello, comma, David? Well, we can do this in a different way. Let me go back over here and, for instance, get just one of those say blocks like this. I'm not going to worry about saying it for some number of seconds because I'm only going to say one thing now. But I somehow want to say hello, comma, and then the user's name. Well, if I poke around further, and you would only know this by having seen it before, turns out there's this puzzle piece down here called join. And it's a little weird that the default words are apple and banana, but those are just placeholders. If I go ahead and drag this over here, it grows to fill, and it overwrites what was there. I can say hello, comma, and then instead of hello, banana, let me go back to sensing, drag the user's answer, and now we say hello, comma, so-and-so. So let's try this now instead. Green flag, type in my name, enter, hello, comma, David. So now the program isn't all that much more complicated, but notice that we're starting to nest these verbs, these functions. We're asking for a name, and then we're saying the result of joining the following two things. So there's a few ideas to keep track of at a time. But this is actually quite like what we were doing from the get-go earlier as follows. For instance, if we want to just say hello world with this puzzle piece here, this actually maps perfectly to our fundamental definition of what problem solving is. The input to that puzzle piece is, of course, just hello world. The function or algorithm that you want to execute, step-by-step instructions for saying something, Scratch calls say in purple. And the output you want, of course, is Scratch saying hello world. Now, in the more sophisticated example, consider this. We asked, what's your name? And then we waited. Well, that picture would look like this instead. The input to that question is, of course, what's your name? The algorithm, or in this case function, via which we're solving that problem is to ask and wait, taking in that input. And the output we get back is now answer. And then lastly, in that third example, where things got a little fancier and you had to start dragging and dropping and nesting these puzzle pieces, notice that this is the same idea. The input now is two things, hello and answer. Those go into a function called join, the output of which should be hello, comma, David. But now we want to pass that output as the input to the say block so that the final result is hello, David, right out of the cat's mouth. So in this way, even with the simplest of puzzle pieces, does everything fit into this same model of problem solving. But let's now make things a little more interesting. Rather than just talk in text with this cat, let's go ahead and have it do some other things instead. Let me go ahead under sound, for instance. And it looks like there's a block in pink here called play sound meow until done. And now let me stop the old program and start the new. OK, little piercing, but adorable. And if you want to hear it again, I can click the green flag. And I can click the green flag. Of course, this is a pretty boring cat if it goes lifeless after it's said just one meow. How would we get it to perpetuate that sound and just meow every few seconds? What construct or idea might we want to use here? Yeah, so some kind of loop. So it turns out in Scratch, there's a few ways to do this. But if I go down to Control, you'll see a couple of blocks here. Repeat some number of times, by default 10, or forever. I'm going to go ahead and maybe do this forever. And I'm going to drag and drop this now into here. Notice I can move things around wherever I want. And now I can reattach this up here. And now play. It's a very agitated cat at the moment. I can calm him down, perhaps, by dragging and dropping this. And notice, even if there's no room, it will grow to fill. 1 second. Now it's a happier cat, if you will. But now that we have the ability to have the cat do something forever, it doesn't have to just do the same thing again and again. It can interact with me or its environment. So instead of playing this sound here, someone following along at home? So instead of playing this sound here, let me go ahead and try this. Let me go to sensing and go ahead to what might I want to do here? Let's go ahead and, under motion rather, under here, point toward mouse pointer. So point towards mouse pointer, and then go ahead and, you know what, move some number of steps. And I'm going to have it move one step or one dot or pixel at a time. And here now we'll get this effect. It looks as though now he'll kind of follow me, right? And as I move my cursor, he is forever pointing toward the cursor, then moving one step. Of course, he's a little slow, and let me go ahead and stop. If I make him take 10 steps at a time, or 10 dots or pixels on the screen, now it's a little harder to avoid. And you can sort of, he'll literally do as you move your cursor here. All right, so now that we have the ability to do something again and again, let's have something count up. For this one, let me go ahead and grab something from online. So on CS50's website, we'll always make available the examples and source code from each class. And this time, I want to go ahead and get this sheep here. So it turns out you don't have to just use a cat. You can use a sheep if you prefer. And let's see, by looking at this code first, what is this sheep going to do? When the green flag is clicked, there's this orange puzzle piece called set counter to 1. What is that? That's an example of, what might we call this? It's called a variable. Now in algebra, we typically use like x and y and z for variables. In programming, when you want to store some value in a placeholder, like a variable, you typically give it more descriptive words, because x, y, and z don't really tell the programmer or someone reading it what it's doing. So we called this variable counter, and we set it equal to 1. Now forever, the sheep is going to do what? It's going to say the counter for 1 second. It's going to then wait for 1 second. And then it's going to change or add 1 to the counter as its final step. So here we have, if you will, counting sheep, whereby it will now just perpetually count up from 1 to 2 to 3, and probably, if we let this thing go, up to infinity. So once we have the ability now to do variables, what if we start to make our programs more interactive and start to remember information? Let me go ahead and into our examples from before and grab another example here now instead. I'm going to go back to what's called a studio in Scratch, where all of these examples currently are. And I'm going to go and open up an example called pet 0. Computer scientists typically start counting from 0, because that's symbolic of like all of the light bulbs being off. And so here's a program now that if I hit play, does not seem to do anything at first. But notice as I move my cursor over, I'm kind of petting the cat now, if you will. So how is this working? Well, he too is just forever listening or waiting for something to happen. It's forever doing this. If touching mouse pointer, then play sound meow until done. So now the cat is being responsive to the user input, not following my cursor, but responding just if I'm actually hovering over him. We can, of course, change this up a little bit in version 2 of this, otherwise known as pet 1, because we started counting at 0. What should I not do with this program? Maybe the don't pet this cat. Why? Well, this time it is forever checking if I'm touching the mouse pointer. And if so, it's going to apparently play a sound roar. Else, it plays the sound meow, which seems to be happening. So here we go. So don't pet the cat. And so that's just a condition asking a question, a so-called Boolean expression, if touching mouse pointer. Well, now let's do something a little fancier still. Let me go ahead here and do this. Let me go ahead and make this one from scratch, no pun intended. And I'm going to go ahead and start with an event when the green flag is clicked. Let me go ahead and grab some motion here. Let me go ahead and grab set rotation style to left, right, just